Welcome to Episode 3 of Plumbing for High-Rise Buildings, Fixture Units, Peak Flow, and NBC versus Hunter's Method. In Episode 1, we calculated daily water demand. In Episode 2, we sized tanks and transfer pumps. But here's the question that separates a draftsman from a design engineer. How do you calculate peak flow for pipe sizing in a 40-story building? Do you use 135 LPCD? Do you divide daily demand by 8 hours? Or do you follow NBC Part 9 fixture unit methodology? Today, we decode the most misunderstood concept in high-rise plumbing, probable simultaneous demand, with actual clause logic and engineering reasoning. Welcome back to the High-Rise Plumbing Masterclass, Season 1, Episode 3. We've sized tanks and transfer pumps. Now we focus on peak flow, which is essential for pipe sizing and distribution design. What is the core topic of Episode 3? Episode 3 focuses on one of the most misunderstood aspects of high-rise plumbing design: how to calculate peak flow for pipe sizing in a 40-story residential building. In Episode 1, we calculated daily water demand using LPCD as per code. In Episode 2, we sized UGT, OHT, and transfer pumps. Now the engineering shifts from volume-based thinking to probability-based distribution design. This episode answers critical professional questions. Should pipe sizing be based on 135 LPCD? Should we divide daily demand by 8 hours? Should we count occupants or fixtures? What does NBC Part 9 legally require? How does Hunter's method compare? This episode builds the hydraulic foundation for riser sizing and pump selection in Episode 4. Why is daily demand not equal to peak flow? This is the most fundamental distinction in plumbing engineering. Daily demand, LPCD, used for storage sizing; UGT, OHT, transfer pump sizing; peak flow, WSFU, used for pipe sizing, riser design, distribution pump selection. This separation is clearly defined in the National Building Code of India, 2016-Part 9. NBC structurally separates water demand calculation, storage requirements, pumping provisions, distribution sizing based on fixture units. Daily demand represents total volume over 24 hours. Peak flow represents maximum probable simultaneous usage. They are not interchangeable. Where exactly does NBC define peak flow methodology? In NBC 2016-Part 9, Section 1, Clause 4.1, Water Demand, defines per capita water requirement, LPCD, daily demand calculation method. Clause 4.2, Distribution System, states that the design of water supply piping shall be based on the probable simultaneous demand derived from fixture units. Table 6 Water Supply Fixture Units, WSFU, provides standardized fixture unit values for WC, shower, wash basin, kitchen sink, bathtub, urinal, etc. This table forms the legal technical basis for peak load pipe sizing. Why can't we use 135 LPCD for pipe sizing? Let us analyze using an example. Example: 1-2 BHK flat. Assume 4 occupants, 135 LPCD per person. Daily demand equals 4 times 135 equals 540 liters per day. Now ask, does 540 liters flow in 1 hour? No. Does it flow in 30 minutes? No. It is distributed across morning peak, evening peak, kitchen usage, laundry usage, night low usage. Pipe sizing must consider maximum probable simultaneous use, not daily total volume. Therefore, using LPCD for pipe sizing results in either oversizing, if multiplied incorrectly, undersizing, if divided by assumed hours. NBC does not permit this shortcut. What is the case study building configuration? Our case? Our 40-story residential building. Total floors equals 40. Service floors equals 2. Residential floors equals 38. Each floor contains 2 flats times 2 BHK. 4 flats times 3 BHK. Total flats per floor equals 6. Total flats in building equals 38 times 6 equals 228 flats. This forms the basis of fixture unit calculation. What fixtures are installed in a typical 2 BHK? Typical 2 BHK layout: common toilet 1 WC, 1 wash basin, 1 shower, attached toilet 1 WC, 1 wash basin, 1 shower, kitchen 1 sink. Total fixtures installed: 2 WC, 2 wash basin, 2 shower, 1 kitchen sink. Total equals 7 fixtures. Important: we count installed fixtures, not occupants. If only 4 people live there, Why count all 7 fixtures? This is a highly intelligent engineering doubt. Only 4 persons can operate 4 fixtures simultaneously. Why count all 7? Because fixture units are not actual flow rates. They are statistical probability weights. The WSFU method assumes all fixtures are installed. Only a fraction operates simultaneously. Probability changes as building size increases. The reduction in simultaneity is already built into the conversion curves. If you manually reduce fixtures, you double apply probability, leading to undersizing. What are typical NBC fixture unit values? Approximate explanation values. Domestic cold water. WC flush tank. Right pointing arrow 2 WSFU. Wash basin right pointing arrow 1 WSFU. Shower right pointing arrow 2 WSFU. Kitchen sink right pointing arrow 2 WSFU. 2 BHK calculation. 2 WC equals 4. 2 basin equals 2. 2 shower equals 4. 1 sink equals 2. Total equals 12 WSFU. Not 7 flow rates. Not liters per minute. But 12 statistical load units. What about 3 BHK fixture units? Typical 3 BHK. 3 WC. 3 basin. 3 shower. 1 sink. Calculation. 3 WC equals 6. 3 basin equals 3. 3 shower equals 6. 1 sink equals 2. Total equals 17 WSFU. What is total building fixture unit load? Per floor. 2 times 12 equals 24. 4 times 17 equals 68. Total per floor equals 92 WSFU. For 38 residential floors, 92 times 38 equals 3,496 WSFU. This is total building fixture unit load. How do we convert 3496 WSFU to flow rate? NBC provides conversion tables/probability curves. Flow does not increase linearly. If 12 WSFU does not equal 12 LPS, then 3496 WSFU does not equal 3,496 LPS. Using typical NBC curve approximation, 3000 minus 3500 WSFU right pointing arrow, approximately 70 to 80 LPS. So peak building demand approximately equals 75 LPS. This becomes basis for booster pump sizing, main riser sizing, distribution header sizing. What is Hunter's method? Developed by Roy B. Hunter. Hunter developed probability curves in 1940s for American plumbing systems. Used in Uniform Plumbing Code, International Plumbing Code. Hunter's approach. Graph-based probability curve, mathematical simultaneity formula. NBC adopted similar philosophy but simplified into tabulated values. Comparison. Hunter right pointing arrow. Detailed statistical curve. NBC right pointing arrow. Practical tabular method. Both reject LPCD for pipe sizing. Why must domestic and flushing networks be separate? Our building has dual plumbing. Domestic water network, flushing water network. WC flushing tank is connected to flushing riser. Wash basin and shower connect to domestic riser. Therefore, WSFU must be split. Domestic fixture units does not equal flushing fixture units. Risers must be independently sized. Tanks must be independently sized. Pumps must be independently selected. Mixing them violates design logic. How does peak flow affect pump selection? From Episode 1, Daily Demand, 147 KLD Domestic, 98 KLD Flushing. From Episode 3, Peak Demand approximately equals 75 LPS. So, transfer pump, UGT right pointing arrow OHT, equals based on daily demand. Booster pump, distribution, equals based on peak WSFU flow. These are two different hydraulic philosophies. Confusing them leads to wrong pump sizing. What is the most common mistake in high-rise plumbing? Many engineers calculate LPCD, divide by 8 working hours, convert to LPS, size pipe. This is incorrect. NBC clearly separates storage sizing, right pointing arrow, LPCD, distribution sizing, right pointing arrow, WSFU. Shortcuts lead to undersized risers, pressure drop complaints, municipal rejection. What is the probability concept behind WSFU? Let's think intuitively. 1 flat right pointing arrow, 7 fixtures. Probability of all 7 running simultaneously equals very low. 200 flats, right pointing arrow, 1400 fixtures. Probability of many operating increases, but not all 1400. As fixture count increases, simultaneity percentage reduces. That is why WSFU curve flattens. This is statistical load aggregation. Addressing the original doubt again. If one person uses WC, he cannot use basin and shower simultaneously. True, but another person may use second toilet, kitchen may run simultaneously. Washing machine may operate, morning peak overlap occurs. Design must satisfy worst probable simultaneous condition. That is why installed fixtures are counted. What did we achieve in this episode? We clarified where NBC defines fixture units, why LPCD is not for pipe sizing, why all fixtures must be counted, how to calculate total WSFU, how to convert WSFU to LPS, difference between NBC and Hunter, dual network separation, link between peak flow and pump selection. This builds foundation for vertical distribution engineering. What comes next? In episode 4, we apply this knowledge to riser sizing for 130 meters building, zoning requirement, static pressure versus residual pressure, PRV selection, pump TDH calculation, velocity criteria, friction loss calculation, pipe material comparison. Peak flow understanding becomes practical design. Conclusion. High-rise plumbing is not based on guesswork, assumed usage hours, occupant count shortcuts. It is based on code-compliant probability engineering. Understanding WSFU is the turning point from junior engineer to hydraulic designer. Engineering is a demanding profession. Site hours, deadlines, calculations, approvals, it can become intense. So while you design safe buildings for others, don't forget to take care of your own health and well-being. Stay hydrated, manage stress, keep learning, maintain balance. A healthy engineer designs better systems. Make sure you like the video, share it with fellow MEP engineers, subscribe to the channel. Keep engineering, stay strong, stay healthy. This lecture is intended for educational and professional development purposes. All references to National Building Code provisions, fixture unit values, and peak flow approximations are for conceptual understanding within a 40-story case study framework. Engineers must refer to the latest official edition of NBC Part 9, applicable local plumbing regulations, municipal authority guidelines, and project-specific approval requirements before finalizing any design. Hydraulic calculations must be validated using standard engineering practice and manufacturer data. Final responsibility for compliance and safety lies with the licensed design professional of the respective project. Download the Master Engineering package from Telegram channel in description. Subscribe for more design systems that never fail.